All right, test 3, college algebra. Here we roll. So you got 10 questions. They are multiple choice. Cool thing about this exam is that it pretty much goes in order, but there is no section 4.2 in this exam. Every other section is pretty much covered, and there's no 8.7 on this exam either. Okay, so let's start going through these and let's talk about where everything's coming from. A majority of it is coming from 4.3. Okay, so first question. This is coming from section 4.1. This is all about linear equation word problems. Okay, and so if you remember from our video, I talked about some key words that you should be on the lookout for. What are those key words that you should be on the lookout for? Per, yeah, we see it right here. Remember those other words that I said? Each and every. A number that is right in front of these words represent what for us? The slope, that's right. So this number 0.09, that is the slope of our equation. Okay? So that means we know that we're writing y equals mx plus b. Remember that in class, I told you the setup of this would look like y equals your per times x, and then it's plus or minus some sort of fee. And this fee, which represents our b, that's like a one-time fee that you have to pay, as we talked about in class and in the videos that I had as well too. So up here, if you read through just this first sentence, it says that when you rent a moving truck one day, they're going to charge you $27. That's what I'm talking about for this guy right there. It's going to cost us $27 no matter what before I can even take the truck. Okay? So that's what we call the fee. So since we now know the M and we know the fee, if we rewrite this, although now we got to use their terminology, it wants us to use C for our Y, and this x represents our normal x. So C is equal to, what's the per? What's our slope? 0.09 x. And then it says how we know it's a plus or minus right here. It says plus. So which one are we going to choose? The plus. And then what's our fee? What are we going to pay? What? We don't got to pay 9 cents. What do we got to pay no matter what? The 27, absolutely. So there's our equation. So now if we're looking at our answers, that narrows things down for us. It's either B or C now. Okay? To get the other parts of this answer, this is where that last question up here is going to come into play. What is the cost of renting the truck if the truck is driven 120 miles? What are we going to do with this 120? You are going to plug it into the equation. Who is it? Is that C or is that X? That's your X, because right up here it says X is all about miles. So all we need to do now is plug in 120 for the X and let our calculator do the dancing. So we take 0.09 times 120, add 27, and what do we get? So that means the answer has to be that one right there. Go Beans? All right, moving on to question 2. So question 2 jumps into section 4.3. And question 2, question 3, question 4, 5, and 6 are all 4.3 questions. Okay? 4.3, a lot of 4.3 is about the vertex. So a lot of these questions are going to be asking you about that vertex. So what are some ways we can find the vertex when given a quadratic? All right, so the first thing you can do, I like that negative b over 2a. This is what we call, and it's x equals, this is what we call the axis of symmetry. I abbreviate it AOS. So if you want to start finding the vertex, the first thing you're going to do is find the axis of symmetry. And then once I know what x is, how do I find the y value? Say it again. Yeah. You plug it back in. You're going to take this x value and plug it in down here to figure out y. Absolutely. That's the second step. Plug in x and solve for y. Okay? So that's one way. That's the algebraic way, which we'll do. But we could also do it another way. You could just go straight into the graphing calculator and use the tools that we know about. Okay? And in the graphing calculator, you'll be using the max or the min tool. All right, so let's do the algebraic way real quick. Let's find the axis of symmetry. So x equals the opposite of b over 2a. So what is the b value in our equation? 8. You got it. But I need the opposite of 8. Negative 8. All over 2 times our a value. What is our a value? A negative 1. No variables in this. It is a number, so it is a negative 1. So all we need to do now is a little bit of mathematics. So 2 times negative 1. So we got negative 8 divided by negative 2. So what is the axis of symmetry? Positive 4. And this is what the axis of symmetry looks like. It should have x equals 4. Well, since we're very, very smart and we look at our answers, there's only one answer that has x equals 4. And that's going to be B. So this first value of 4, 19, that's the vertex. This piece, x equals 4, that's the axis of symmetry it asks for. Now again, if I want to verify this, how do I get the 19? All we got to do is take the 4 and plug it in here. So you'd have negative 1 times 4 squared plus 8 times 4 plus 3. So what's 4 squared? And 16 times a negative 1 plus, what's 8 times 4? And then plus 3. And when all is said and done, you should get 19 out of that. So that ends up being the vertex, the 4, comma, the 19. Which verifies that, yes, B is our answer. But again, like you said, we could go to the graphing calculator and have it help us. Because we are dealing with a function here, remember that this is just a fancy way of saying y equals. So we are in the form that we can put it in our calculator. So all we got to do is just go put this in, and we can start finding the vertex. So y equals negative x squared. What was the next piece? Plus 8x plus 8x plus 3. Hit graph. Oh, it's a little off our screen. Okay? So maybe we can't use the second trace piece to find that vertex. And remember, minimum and maximum are used to find the vertex if it was on our screen. But we could go to the table. Because in class, when we were talking about this, how do you recognize the vertex from the table? Say it again. Okay, the y values are the same around it. So in other words, the vertex is the only one that has a y value that what? That's different. It doesn't repeat. So the 18 repeats. The 15 repeats. The 10 and the 10 repeat. The 3 and the 3 repeat. But this guy right here, 19, this is unique. there is no other y value that has 19. This guy right here is your vertex if you're looking at the table. Remember, look for the y value that does not repeat. But again, the table doesn't always have that because maybe the y value is not so nice and neat sometimes. So just be careful on the table, although we are going to be nice and we're going to try and make it so that you could probably use the table to find this. Okay? But again, if you had the graph and if we expand this out, which we can always expand our graph out. We can go to our window and we just need to make it taller. So that means we want to mess around with the y max. Since we already know where the vertex is at, I'm just going to make the y max 20. And now if I hit graph, now I can see it all. And again, we could run second trace. Would I choose a minimum or a maximum? Well, who is that guy? It's a maximum. Second trace. Go down to maximum. Remember, it asks you 3 questions. B to the left, B to the right, and then guess. So I'm going to scroll over just a little bit. And I'm going to B to the left, enter. And I'm going to scroll over. I'm going to B to the right, enter. And now I'm going to scroll where I think it's at and hit enter. And there it is. Now again, your graphing calculator is doing some extrapolation down here. This number really means 4. So go ahead and round this up to the 4. If it was 3.000001, because sometimes that happens, you would have just made the number 3. So know that you might have to do a little bit of rounding on here. If you see a lot of 9s in the end, round it up. If you see a lot of 0s in the end, just basically drop them. So you can see that our vertex is 419. Okay? So there we go. 2 ways to look at question number 2. You can do it algebraic, or you can use that calculator to help you out. Also, when it comes to your calculator, when you're ready to go back to a new problem, we need to fix our screen. How do we do that again? Because we've messed with it. We're going to go to what? Zoom and standard. And that will fix our screen. So now it's back to normal. Go in here and clear that out, and now we're ready to do some more. All right, so let's take question 3 up. So this time it says graph the function. Oh, weird. What are we going to do with this? Plug it into the calculator. But again, we could actually do all this information by hand, but let's go to the calculator and let's plug it in and do what it says to do. So this time we're going to go to our calculator. We're going to plug this in. Negative x squared plus 6x minus 8. So negative x squared plus 6x minus 8. Graph. And there it is. All you have to do now is take your calculator screen, come over here, and look to see which graph it is. This should be a no-brainer. What do we got? What do you think? Is it A, C, B, or D? It's D. Now, let's verify some of this other information because it's important to know. But this is just working smart. Use those answers to your advantage. Nothing wrong with that. So if we come in here, we can find our vertex. Remember, we just talked about that. We can do it 2 ways. We can do second trace. And was that a maximum or a minimum? So we can run maximum. And again, we're going to scroll over and we're going to be to the left. We're going to scroll and be to the right. Then we're going to guess. Close enough. And there it is. Here's what I was talking about. All those zeros, just drop them. So our vertex is 3, 1. Oh, look. 3, 1. Okay? Or, again, you could go to the table. And if you look, oh, look. This is the only y value that's not repeating. 3, 1 is the vertex. Cool? And then it also asks, What are the intercepts? Well, if you're looking at the table right now, you can see the two x-intercepts. Yeah, the 2, 0, and the 4, 0, because x-intercepts happen when your y value is 0. You can also see the y-intercept up here. 0, -8. There you go. Those are all the same points that they had listed right there. So remember, those x-intercepts, look and see what happens when the y value is 0. Those y-intercepts, look and see what happens when the x is 0. But you don't have to use the table to do that again. Remember, there are other ways. We can go into our graph. Under second trace, which one up here will find the x-intercepts? The 0. So you scroll down to it. And again, this is going to act just like the maximum minimums. It says B to the left, B to the right. Take a guess. So I'm going to scroll to the left of my first 0, enter. I'm going to scroll to the right of my 0, enter. I'm going to take a guess, enter. And there's your first one, which is what we saw on the table. Run the same program to do the other one. But again, you can also look at this and it makes sense. 2, 0, 4, 0. What would I use on here to find the y-intercept? Value. Because what is the x value for a y-intercept? 0. So you plug in 0 and you hit enter. There's your y-intercept. Okay? So two ways. You can look at the table. You can look by using the second trace functions to get all that information. If you wanted to, you could easily do this by hand too. We already talked about how to find the vertex. You do x equals the opposite of b over 2a. And then we're going to take this answer and plug it in to find the y value of the vertex. If you wanted to find the x-intercepts, plug 0 in for y. And you solve for x, which you could use factoring or the quadratic formula on. If you wanted to find the y-intercepts, plug 0 in for x. And solve for the y value. Of course, these would be in parentheses. And there you could do it by hand if you wanted to. Okay? Any question about question number 3? You can do it algebraically or you can use your calculator. All right. Question number 4. Determine the domain and range. All right. So first things first. We already know how to find domain of equations. When we find domain of equations, we always assume what in the beginning? That it's all reals, unless radical. Good. Unless we are a rational, which looks like a fraction. Does this thing look like a fraction? Nope, we'll get to that. That's module 4. Or we're a radical. Do I have any radicals in here? So in this guy, the domain is what then? All reals. So now we know our answer is either A or B. In fact, all quadratics, the domain is always all reals. Unless it's in the context of the real world. Then things change on us. But other than that, in quadratics, the domain is all reals. All right. So with that being said, now we got to talk about the range. In order to find the range, you can do one of two things. We can do it algebraically, or we can graph it. Absolutely. Let's talk about the graph. So let's take this and put this in our graphing calculator. So Our equation was x squared plus 8x. Whoops. Get rid of that parenthesis. Plus 16. Graph. So there's what it looks like. So the range is all about the y values, right? So remember when we talked about this in class, it's kind of like you're going to take a rocket ship and strap it to your back, and you're going to fly up, and you can only look left and right, or you can dig down and look left and right. But what we want to know is we want to know where we can no longer see our graph. So if I'm digging down into the ground here, do I see my graph anywhere down here? No. When do I start to see my graph? At 0. And as I move up, is there any place where I will not see my graph? No, we'll still see it, even as we travel up here, because this guy's going to keep going that way and that way and that way and that way, up and off the board. And we're going to keep going up, and we're always going to be able to see our graph even up here, because the graph will be on both sides of us. Because this graph keeps going up, and over here it keeps going up. So what is the range? What's the lowest we can go? 0. What's the highest we can go? To infinity and beyond. So our range, you told me in interval notation, looks like this. 0, and we like it because we can see it, to infinity, right? So I need to know which one of these I should pick. A, because that's the one that says we want to be greater than 0. Actually, greater than or equal to 0. Boom. There it is. Another way you can think about this is once you know the vertex of this, because we can find the vertex algebraically, the vertex of this guy algebraically is -8, comma 0. Why am I writing it like a fraction? I'm so weird. Let me go back. Let me look at the graph real quick. Sorry, -4. That's why I was. -4, comma 0. And again, you can find that algebraically. Do the opposite of b over 2a. That gives you the -4. Plug the -4 in, and that gives you the 0. When it comes to the range, it's all about this guy. Okay? Because it's all about the y value. So you know that your range should do something with 0. And you're either going to be above 0 or below 0. How do we know which one we're going to do? Look at the a value, because we talked about a before. A is all about whether it reflects over the x-axis or not. So because a is positive, that means this thing opens up. So that means our range, because the a is positive, is going to be y greater than or equal to 0. Because this is the lowest you're going to go. And because your a is positive, it opens up, meaning that we want to be bigger than that number. If this a value was negative, that meant it would have opened down. And you would have been a less than or equal to. So there's how you can do it algebraically. Again, find the vertex like normal, and then it's all going to be about the y value. And you're either going to be greater than or equal to, or less than or equal to. How do you know which one it is? Know whether this thing opens up as a U or as an arch. And again, it's a U if a is positive. It is an arch if a is negative. All right, moving on. Question 5. So it wants to know, where is the function increasing and where is it decreasing? What can we do with this information? We can graph it. Okay? And again, everything's going to be about the vertex. And remember, increasing and decreasing is always in parentheses and deals with x values. Okay? So let's go to our graphing calculator. And we're going to put in our equation, which is negative x squared plus 6x minus 8. Graph. So first things first, you want to know what the vertex is. Okay? So if we look at this, we've seen this picture before. What is our vertex? No. That's a positive 3, 1, right? And again, you can verify that using the table. Look, there's the only y value that doesn't repeat. Or you could have used second trace and done a minimum or a maximum. In our case, it would have been a maximum. All right, so now that we know the vertex is 3, 1, my answer should contain which one of those values? The x, which is 3. So now I can come down here, and I know that C and D are just junk, because 1 was the y value. So my answer is one of these two. Now we just go back to the graph, and all we got to do is figure out what's happening. So as I come over here from negative infinity to the 3, what's my graph doing? Increasing. So from negative infinity to 3, it should say increasing. What's happening from 3 as I move towards positive infinity? It's decreasing. So I need an answer that says from negative infinity to 3, I'm increasing, and from 3 to infinity, I'm decreasing. Hey, and there it is. Okay? If we work this algebraically, because you can do this algebraically, you find the vertex. Actually, we don't even need all the vertex. All we need is whatever x is, right? So find that axis of symmetry. Opposite of b over 2a. Once you know what x is, which in our case is 3, this is where we go back and we think about, is this a U or is this an arch, like what we did in the previous problem? So we look at our a value up here. Our a value is what? Negative. So that means, is this going to be a U or an arch? It's going to be an arch. And right there, you now know how it's going to increase and decrease. The beginning of my graph will be increasing till it gets to the 3, and then it will decrease. Okay? So from negative infinity to 3, we're increasing. From 3 to positive infinity, we're decreasing. Okay? So you can use the same information. You can think about it algebraically, or you can go into the graphing calculator, have it help you out. A lot of cool things the graphing calculator can do. All right, last one. It says determine the quadratic function whose graph is given by this. All right, so this one, we can use those answers against them. Because all of these are quadratic equations, right? What can I do with each one of these to figure out which one it is? So this is the graph. So, it's positive, right? It's got a positive A because it's a U, right? So right now you narrowed it down to 2. Which ones could they be? B or C. What can we do now? You can use a calculator, right? Use it against them. You don't have to do a lot of algebra on this unless you want to. I will show you the algebra here in a second. But just go to the calculator. Let's plug in the first one and see if it gives us that same picture. So x squared. Whoops. Stop it. No. Silly board. Plus what? 8x plus 2. Does that graph like what we have on our paper? No. So obviously the answer should now be C. But let's double check that and make sure. Okay? So let's go in and let's plug in x squared minus 4x plus 2. Okay? X squared minus 4x plus 2. Yeah, that looks like it. Okay? So right there, you just use a graphing calculator and get your answer. Now, you can do this by hand, algebraically. In class, we talked about that we can use what we call vertex form. Remember, vertex form looks like this. A, x minus h squared plus k. Because remember that the vertex is in the form h comma k. Also remember that in this, we're going to be nice and we let a equal the value of 1. Okay? We're going to be nice on that. Most problems you actually do usually have to figure out what a is, but we're not going to worry about that. We're just going to let a be 1 all the time. So all we got to do now is plug in the a, the h, and the k, and we'll do some rearranging. Okay? So first, let's look at our picture. Up here, who is the vertex? 2 comma negative 2. Good. All right. So 2 comma negative 2. This is h. This is the k. You already know what a is. So all we got to do is plug in. Okay? So we've got 1 parenthesis x minus, what's my h? 2 squared. And then plus, what's your k? Negative 2. So if you want, instead of saying plus a negative, you could just call it a minus. Now, what we have to do is, because this is not the final answer, we need to square this parenthesis, which means that we really need to FOIL. And then we will subtract 2 from the answer. Okay? So remember this guy. Do not take the 2 and distribute it through. That's not how this works. This square means that you have 2 of those parentheses. You need to FOIL. You need to FOIL. Okay? So, what's x times x? X squared. What's x times negative 2? What's negative 2 times x? What's negative 2 times negative 2? Okay? Now remember, all this is surrounded with a parenthesis and a 1 in front. But is that 1 in front going to do anything to that? No. Oops, should be a positive 4 there. Almost forgot that. So technically, we can just drop the parentheses because this 1 isn't going to do anything to that. And we can then combine like terms. So technically, we don't need this information. We don't need that parenthesis. We don't need that 1. We don't need that final parenthesis there. Let me fix this part. Plus 4. All we got to do now is combine like terms. The x squared stays. Who's getting together with negative 2? The negative 2x right next door. And what's negative 2x and negative 2x? Negative 4x. Who's getting together with the positive 4? The negative 2. What's 4 minus 2? It's the same answer we highlighted. So you can use the calculator to test each one of those and see which one it is. Or this is the algebra that goes behind it. You can run the algebra. Your call. Okay? All right. So we are out of 4.3 now. The next two questions, question 7 and question 8, are all from 4.4. Do you see any words in here that are of note to us that might mean something? Maximize. Maximum. What do you think they want us to find? The vertex. That's what they want. So we want to find the vertex, and this will tell us what x is, and then this will be the y value of it. Now, the first things first, though. This problem, you got to do a little bit of work first. You need to remember, make a note of this. This problem is all about revenue. If you want to find the revenue that your business is doing, what you're going to do then is you're going to take your x, which in our case, x is the number of sold product, and you're going to multiply it by the price, which makes sense. Because how many I sell times how much it is how much money I'm making. So you need to remember this little formula, because this is what's going to help us set up the problem. Because right now, if you look at this piece that's right over here, this equation, that's not a quadratic. That's a linear. Okay? Which is why we have this information. So if I want to find the revenue equation, I need to take x times p. But what is p? The price. But what is the price? And what are we going to do with that x in front? You're going to distribute. What is x times negative 1/6 x? Negative 1/6 x squared. Oh, look, quadratic now. What is x times 200? This is the equation you need to use to find the maximum and the minimum. Now, we can go under our calculator, and we can have our calculator help us out, but we got to do a lot of window adjusting. This is where I'm going to rely on the algebra skills. Okay? How do we find the vertex of a quadratic? What do we do first? The negative b over 2a. Find that axis of symmetry, AOS. And this is going to be the answer for x, which is really cool because we're going to use their answers against them, because every answer up here has a different answer for x. Once we know what x is, we're actually going to know the answer. So up here, I need b. What is b up here? 200. But what's the opposite of 200? Negative 200. So there's your top value. Divided by 2 times, what's a? Negative what? Okay. Negative 1/6. So This is where I'm going to let my calculator do the dancing. Okay? I'm going to go into my calculator, and we're going to put this in exactly the way we see it. Okay? It's a fraction with another fraction in the denominator. Okay? So where's our fraction key in here? Let's clear that out. Alpha y equals. What's my top number? Negative 200. In the bottom, I have what? A 2, and then a parenthesis, right? And then it's a fraction. Where's my fraction key again? Alpha y equals. And this is a negative 1/6. Close. Looks just like what's on my paper, right? Hit enter. There's x. So what is our x value? And so that means that we sold 600 units, whatever those units are. I don't think it tells us up here. Nope. So if I sell 600 units, that maximizes my revenue. And so that leads us to what answer? B. And how would I verify the 60,000? What would I do with this number? We'd plug it back in. We're going to take this value right here, and all you're going to do is you're going to plug it into x and plug it into x. So you would have this looking equation. Negative 1/6, 600 squared minus 200, plus 200 times 600. And again, you can go right into your calculator, plug that in the way that you see it. And this will kick out the 60,000. So let's go plug that into our calculator. Where's my fraction key? Alpha y equals. And it is a negative 1/6. We put a parenthesis. What's inside? 600. Close the parenthesis. And it is squared plus 200 parenthesis 600 close. Just like what's on my paper. 60,000. Cool beans? All right, so that's a good question. So the question is, can we plug it back into the original equation, the P price? And no, we don't want to plug it into this because P represents price. We want revenue. Hence why we have to plug into the equation R. R for revenue, P for price. So definitely make sure that you know who you got to plug into, okay? This was all about revenue. So it's all about this guy. You wanted the vertex of that, okay? And these two numbers represent the vertex. This is the x value. That's the y value. Okay? All right. Question number 8 is a lot like this. See any words that are of importance? Oh, maximum. So what do they want us to find? The vertex again. Okay? And specifically in this one, it says how many seconds. So who are we looking for then? H or T? You're looking for T. So in our case, all we're doing is finding the axis of symmetry. How do we find the axis of symmetry? There you go. That's all we got to run on this. So who's your B? Nope. B. Say it again. Nope. Your B. The 390. That's your B. But I need the opposite of that. Negative 390. 2 times, what's your A? That's your negative 15. So all we got to do is go to our calculator. Let it do some handy-dandy calculating. Okay? So calculator, where's our fraction key? Alpha y equals, what's my top value? Negative 390. What's my bottom value? Parenthesis, close it, boom. So, how long does it take to reach the maximum height? So the answer is A. Cool beans? Yeah. If you haven't noticed, a lot of this test, like from question 2 all the way through question 8, is all about the what? The vertex. Vertex is everything on a quadratic. All right, question 9 and question 10. So question 9 is going to come from 4.5. Question 10 will come from 8.6. All right, so we want to solve the inequality. So what's the first thing you need to find on this? The x-intercepts, the critical values, which in our case are the x-intercepts, or what we also call solutions, or zeros or roots. Remember, all those mean the same thing. X-intercepts, roots, zeros, solutions. So, is this good to go the way it is? Yes, because we're equal to 0. Remember, we don't worry about this part until the very, very end. So the first thing you're going to do is you're going to find the x-intercepts to this. So we can factor it. How else could we do it? We could graph it, or quadratic formula. You got it. Those are the 3 methods I would say to figure out what your x equals. Factoring, that's always my number 1 choice to go to. And then after that, graphing, that would be my number 2. The last thing I would do is quadratic formula. So, you said this thing factors. What does it factor to? All right, you're close. This would actually give you a positive 4 in the middle. So how could I fix this? This is really close. That would give me a positive 4x in the middle. There we go. Change the 7 to be the negative guy and the 3 to be the positive guy. Now that will give me a negative 4. All right. So then what are the critical values? There we go. So now you look at a number line. What's our lowest critical value? Negative 3. What's our highest critical value? 7. And what you have now done is you have made 3 intervals. What is this interval that's right here? What is this interval? From what to what? Negative infinity to negative 3. What is this interval? Negative 3 to 7. And what is this interval? 7 to infinity. Okay? Now, we have these intervals. What we need to do now is test some information, because we got to know what's going on here. And by got to know what's going on, we got to know what kind of answers do we have. And all we want to know is, are they positive or negative answers? So in here, I need a value I can test that is less than negative 3. Negative 4. Good job. I would do that one. Okay? I need a value in here that is between negative 3 and 7. 0 is a great value. And then over here, I need a value that is bigger than 7. 8. So we're going to test these values. Testing means we want to take the negative 4 and we want to plug it in here and see if the answer is positive or if it's negative. That's all we care about. We don't care about what number it is. We just want to know, are you positive or are you negative? So if we take negative 4 and plug it in, Is that positive or is that negative? Should be positive, and I agree with you. Because this is a positive 16, this is a positive 16, that's a negative 21. The positives are going to overrule the negative. So we know that any number we choose in here that's less than negative 3, the answers are always positive. All right? So now, well, we want to see what happens if we plug in 0. What kind of answer is that? Negative. Good job. And then last but not least, you'll want to know what happens if we plug in a positive 8. Will that be a positive answer or a negative answer? It should still be positive. You bet. Again, we don't care about the numbers. We just care about whether it's positive or negative. And then now we're on the last step. We've got everything we need. Now we worry about this. So this says we want to be less than or equal to 0. What does that mean, being less than or equal to 0? What are we looking for? What kind of numbers are less than or equal to 0? Negatives. So we want to know where is it that we have negative answers. And where is that going to be? In this interval, because this is where all the answers are negative. So this is the interval that we want for the answer. Now the question is, are they brackets or parentheses? How'd you know it was a bracket? Because we're equal to, yeah. This is the answer. Because that's the interval that we have negative numbers for answers. And it's a bracket because we're equal to. So up here, what is the solution? A, B, C, or D? C. And there we go. There's question number 9. Last question. Number 10, again, comes from 8.6. So it says the graph of two equations along with the points of intersections are given. Substitute the points of intersections into the systems of equations. Are the points of intersections solutions to the system? So all they want us to do is check both of these by plugging in. Double checking and making sure that they are solutions. Okay? So again, just remember, points are made up of x and then y. So let's plug into the top equation and see if it works. 17 equal to negative 2 times x, which is negative 4, plus 9. So what's negative 2 times negative 4? 8. And what is 8 plus 9? So that checked out, right? Now let's check the second equation. As long as it checks out in the second equation, we're good to go. So we've got negative 4, and we're going to square it, equal to 17 minus 1. What's negative 4 squared? 16. Is 17 minus 1 16? Yep. Checks out. So this point is good. Now we need to check one more point, the 2, 5. So again, all we're going to do, this is x, this is y, plug in. So we have this time 5 equals negative 2 times 2 plus 9. What's negative 2 times 2? What's negative 4 plus 9? Is that 5? So far, so good. Now we check the last one. So we've got 2 squared equal to 5 minus 1. What's 2 squared? What's 5 minus 1? Did it check out? So the answer is Yes. Because both points checked out. If one of those would have failed, we would have answered no. That's your exam.